In this video, let us continue to solve more problems based on arithmetic progression. And we've got a problem here which reads like this. In a flower bed, there are 23 rose plants in the first row and 21 in the second row, 19 in the third row, and so on. Well, as you can see, it decreases by 2. So it definitely is an arithmetic progression, right? So there are 5 plants in the last row. How many rows are there in the flower bed? So yeah, the problem says, it starts off with 23 rose plants and then it decreases 23, 21, 19 and so on. And then it ends in 5, right? So the AP is like this, 23, 21, 19 and then so on. And it is in 5. Of course, this is a small thing you can definitely write and then find out. But that's not the way to be done. We need to solve it using the concepts of arithmetic progression. So now, what we have to assume is, based on the question, they've asked how many rows are there in the flower bed. So that means what? What is the total number of terms in this arithmetic progression, right? So that's going to be n. So I'd say let the number of rows be n. Let the number of rows be equal to n. So now the sequence is this, with A as 23 and the difference between the terms is -2, because 21 minus 23 is -2 and 19 minus 21 is -2 and so on. So we've got A and D. So we need to find n. So we have an equals A plus n minus 1 into D, right? So this an is known, that's 5. We don't know which term it is, which row it is. Well, that term is nothing but row as far as this problem is concerned. So we've got A, which is 23, and plus, what's n here? Well, we don't know n, so n minus 1 times -2, right? So now we just have to solve this. So we've got 5 equals 23, so this becomes -2n. -2 into -1 is +2. So we have 5 equals 25 minus 2n, or 2n equals 25 minus 5, which is equal to 2n equals 20. So n equals 20 divided by 2, which is 10. So therefore, the number of rows in the flower bed is equal to 10. So there are 10 rows in the given flower bed, or there are 10 rows of rose plants. So it's a pretty simple problem. It's just that it is given in the form of a word problem. Otherwise, the concepts are nothing new as compared to the ones that we previously solved in arithmetic progression. So before I end this video, let's quickly solve another problem. So here we've got another problem. It says Subba Rao started work in 1995 at an annual salary of rupees 5,000 and received a rupees 200 raise each year. In which year will his annual salary reach rupees 7,000? Well, so annual salary received by Subba Rao in 1995 and so on will be like this, rupees 5,000. It increases by 200 every year, so it will be rupees 5,000, rupees 5,200, rupees 5,400 and so on, and it reaches rupees 7,000 at one point, right? So this is 1995, this is 1996, this is 1997, and this is what we have to find out. Or in other words, let us say this is the first year, this is the second year, this is the third year, and this is the nth year, right? So we need to find n. So what is n? So once we get n, we can add that to 1995. That is, say if it is 7, then add 7 years to this, and then you go there. That will be 2002 or something. So something like that. So now this is the first thing. So this will be A equals 5,000. And the difference by how much it increases, it is D equals 5,200 minus 5,000, or 5,400 minus 5,200, which is 200. So now we have to find which term is 7,000 is. So right, so it is an equals A plus n minus 1 into D. So an is 7,000, A is 5,000. We do not know n, so n minus 1 times 200, right? So now we have 7,000 equals 5,000 plus 200 n. 200 into n is 200 n. 200 into -1 is -200. So that will be 7,000 equals 500 minus 200 is 4800. 4800 plus 200n. So this becomes 200n equals 7000 minus 4800. So 200n equals 2200. So n equals 2200 divided by 200. That is nothing but 11. 200 goes 11 times in 2200. So that is n is 11. So that means it is the 11th year. If this is the first year, this is the second, this is the third, this is the 11th year. So 11 years from 1995, Subbarao gets his annual salary to reach rupees 7000, right? So if this is first year, his 11th year will be, his 10th year will be what? 1995, 1996 is the second, 1997 is the third, and so on. The 10th will be 2004, the 11th would be 2005. So after 10 years from 1995, Subbarao will get a salary of rupees 7000. So the year is the year in which Subbarao gets his salary to be equal to 7000 is the year 2005. We can quickly check that. Say 1995, 1996, 1997, 1998, 1999, 2000, 2001, 2002, 2003, 2004, 2005, and so on. So if this is the first, this second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, this is the 11th. So this is the 11th term. So the 11th is this 2005. The year is 2005. So that's all. Again, the basic concepts of arithmetic progression. Otherwise, pretty, nothing much different. Of course, it's a word problem. Otherwise, it's all the same. So this ends this problem as well as this video. I'll see you in the forthcoming videos with more concepts based on arithmetic progression.